Yeah. All is good. Quite the mic stand. All right. Yeah. Sounds good. Just swing it around. Thank you.
When I get a clip, I'll swap it.
Yeah, no worries. All right, we will get started in a minute. We're waiting on some elevators for some people. That's a good way to think of it. All right, we'll give it about 60 more seconds, and then we have a fairly packed agenda, so we will get started chucking through there. All right. Welcome to Mask at IETF 115. This is yet another session that is being recorded. At this point in the week, you probably know how to do this, but if you don't, use the QR code over there to bring up the on-site tool if you're in the room. If you're not in the room and you're hearing this, you've already figured that much out. And you can enter the queue by raising your hand, leave it by lowering your hand, and when it's time to speak, please do state your full name before speaking. This is the IETF note rail. Please take time to read it. These are the terms by which we participate in the IETF. Also note that this includes a code of conduct, so please be respectful of each other. If you're in the room, we also have a mask policy at IETF 115, so you need to be wearing a mask at all times in the room unless you are actively speaking into a microphone. We have some fun and helpful links. Notably, we've moved Jabber over to Zulip. If that link doesn't work, let me know and we'll go figure out a better way to link to it. And we have an absolutely packed agenda for today. So we're going to start off by talking about our remaining working group document, which is Connect IP. We're then going to work our way towards discussing some proposed text for a recharter. And on the way to that, we're going to run through a fairly long list of other proposed extensions and additional work. And part of the goal of this is to take a look at these items and say, where do we draw this line? Where do we say, yes, these are things that we want to be in scope, and which things do we want to be out of scope? So we're going to take a quick tour through a long list of things, some of which we've talked about before, and we'll talk about those a little more briefly now. Some of them are new. Before we do that, however, Connect IP is our last remaining item because our first two items are now actually RFCs. So huge congratulations. 9297 is HTTP datagrams in the capsule protocol, and 9298 is Connect IP, which we named proxying UDP and IP in HTTP. So very nicely done. Thank you to everybody for all of the awesome feedback and super hard work. And yeah, let's give ourselves a hand. With that, Alex, I believe you are up with Connect IP. Yes. I granted your request, but I can steal it from you too if you want. That works too.
Hello, everyone. Can you hear me okay? Excellent. I am Alex Chernachovsky. I'm one of the co-authors of the MASQUE Connect IP draft. I expect none of you are surprised to see that we are presenting this today because we've been talking about it for the last couple of sessions. Next slide, please. So I wanted to start out by talking about our progress from the hackathon. We had a very packed 2 days in which we sat next to the Ericsson folks and some of the Apple folks who were working with us, and we managed to get every client that exists talking to every server that exists, which is amazing news because at the beginning of Saturday morning, this entire matrix would have been empty. This is very cool. Unfortunately, our friends at Apple did not have a server implementation for us to test against, which is why the Apple column is all gray boxes. But, given the fact that we had 3 clients and 2 servers, I think this is amazing progress. Next slide, please. So what actually enabled us to get here is if you actually go and look at the GitHub issues. Prior to this session, at the end, well, sort of 2 weeks after IETF 114 in Philadelphia, we had about 7 issues that were open and we were discussing as a result of that meeting. And I am very pleased to say that all 7 of them are currently closed, meaning that there are no outstanding issues on the draft. So I'd like to go through in detail what all of these different changes were. Next slide, please. So the first thing was around MTU. One of the things which is very interesting, of course, is that MTU tends to be both a hop-by-hop but also end-to-end property. And when we add all of these different layers of encapsulation, we are, of course, taking away the MTU. IPv6, of course, specifies that we want to have a minimum of 1280 byte MTU. So we have some interesting questions about what to do if you cannot support that. So one of the things that we added was some text that clarified that the ICMPv6 method that we described that was previously optional must be used when intermediaries are in use unless you have out-of-band information that the path MTU is sufficient. We also added a bit of text that says that you must abort a connect IP stream if the quick MTU does not allow sending 1280 bytes if you're using IPv6. So this basically clarified a whole bunch of different edge cases that previously were there. Of course, if you want to use streams, that would be fine. You just can't do this over datagrams. Next slide, please. We also clarified some details around some ICMP errors. So previously, we just had a small paragraph in the document that said, go look at RFC 4443, and didn't really provide any additional information as to how you would actually use the information in 4443 in these contexts. So after the working group pointed this out, we went back and added some text that said, go look at 792, look at 4443, and here's some specific guidance on which error codes to use when, for example, you get an invalid source address or an unwritable destination, or packets cannot fit inside the MTU. We also added another clarification, which is one that came up from Philadelphia last session, which was what happens if you're using IP proto scoping with Connect IP and you haven't asked for ICMP packets. We've said, well, you probably should. You should ask for ICMP. And but you also need to be prepared to also receive them. If you're not using any route advertisement capsules, then there are some recommendations in the text for how a Connect IP proxy should go and actually grab out those signals directly to learn those error codes. So that, again, helps handle how a whole bunch of errors previously were a little bit ambiguous about. Next slide, please. Another feature that was added, which was found when we were working through this, is that previously Connect IP, the address request capsule, basically provided a mechanism for you to say, I want this specific IP address or this specific subnet. But it didn't have a way for easily specifying, well, just give me an address. But it turns out this was already something we had planned ahead for, but we had just forgotten to write text on. You basically go and request the all zeros address with a subnet mask of the desired size. So for example, if you're an IPv4 and you want an entire /24 subnet, you would ask for 0.0.0.0/24, and the server would give you back some /24 if it had one available. This is obviously much more usable in IPv6 land than it is in IPv4 land, but hey, you can ask for individual addresses the same way. As always, a mass Connect IP server doesn't need to respond to you successfully with this request. It's always allowed to say, well, I can't satisfy that, but at least with an any address, assuming that there's actually IP resources available, it should always be able to give you back what you ask for. Next slide, please. Another issue which was quite contentious at 114 was the cross product of the fact that you can have unsolicited address assignment capsules be sent, but also that we don't necessarily guarantee a reply to any sort of IP address request capsule. And also what happens if you need some address, which you do, in order to send any amount of packets. And Martin Thompson rightly pointed out that this probably means you have to wait for a timeout in the current scheme in order to be able to start sending your first flight. So After a lot of back and forth, we concluded that the best way to fix this was to add request and response IDs to these capsules so that that way you can tell which address assignment response correlates with the different requests that you sent. So now you can easily tell apart, oh, the server sent me an unsolicited address assigned that I didn't ask for, so I can at least start using it. It might not be the one I asked for, but hey, I can do something. So now you don't have to have a timeout in order to wait for some address assigned capsule that will never arrive, for example. Next slide, please. Another thing that was brought up was, do we want to split the address request and address assigned capsules, which currently support both V4 and V6 fields, into separate capsules? And after a bunch of discussion amongst contributors and the editors of the draft, we basically concluded that it didn't seem to have any benefit to do this split. So we decided to leave it as is. Next slide, please. So at this point, you probably realize that we went through this presentation fairly quickly because no one has come up to the queue and asked questions, which means I have a question for the working group, which is, do we think we are ready to proceed to working group last call? I personally think that we have made excellent progress. We have no open issues, and I'm not sure what else we could do. So if anyone else would like to go into the queue and offer an opinion, I'd love to hear it.
David Skenazy, mask enthusiast, with an opinion. The draft was in good shape. We made like really good progress at the last IETF, and we were all thinking, well, yeah, the text-wise this seems good, but you know, let's see if it actually works before we go any further. And it was quite great at the hackathon this weekend to see that like some of the design choices that we made ended up being even better than we thought. So for example, the like, let's just use ICMP for signaling. We realized that we got that feature for free because we have the kernel taking care of that for us. So that was kind of nice. Of like, why are you sending me this? Oh, that's an ICMP packet. Oh, great. We don't need to implement anything. That's automatic. Things like that. And the, what's going on here with, anyway, so we're pretty, I'm personally very happy with where things at. I think maybe the editors can do an editorial pass before we launch the working group last call, but I think that's the only thing. There aren't any open issues, and that'll be a good way to motivate people to read the draft. So maybe give us a few weeks to do editorial work, and then we're ready for that, I think.
I will also say at the hackathon, almost all of the issues that we ran into on interop weren't on Connect IP. They were like, oh, you screwed up your Linux routing firewall, or oh, your certificate's not a valid X509 cert, which is, you know, the best kind of problems to have, things that we should have been able to fix going into it anyway.
Yeah, I think we had one instance of, oh, right, you didn't update to this version of the draft for the capsule types, and then everything else was IP tables, die. But then we got it working.
Martin Duke, Google, and MASQUE-AD. Thanks for your to everyone for their diligent work on this. Seems like you're very efficiently, solving the resulting issues. I wonder if this might be a good time, since you've figured out how to spell everything, to maybe do an early int area review, so to avoid issues coming up in IETF last call. I mean, I'm fairly optimistic that it'll be fine, but it's always a good thing to get it done. Yeah, that would be fine.
Thank you for the recommendation, Martin.
Yeah, we can run those in parallel. I think Lorenzo is up next.
Lorenzo Colidi, Android. So I haven't read the draft. I was just reading it now. Yes, shoot me now. But that gives me a unique perspective of being able to ask a generic question. The question is this. This feels like a really sort of like low layer thing. And one thing that we have, unfortunately, in Android is that applications use the BSD sockets API very extensively. And there's a lot of warts in that, like dual stack sockets and automatic port assignments on bind, a lot of assumptions that apps make. My question, which is super generic, is, has anyone looked a little bit at how to map the sort of semantics of the system calls that apps use, like bind or connect, to this? Because this is very packet oriented, right?
Thank you, Lorenzo. That is an amazing question. So there's two ways to use Connect IP. The first of which is this is more like a traditional VPN with a virtual network device where the individual applications don't have to worry about this. And in the case that we have today, which is, I think, how one of the Google implementations that we interoperated with worked, it like literally brought up Linux ton devices on the client side, and basically, we didn't actually do netlink to set the routes, but you can go and set your routes to go through this device, and all applications which are making requests or handling responses naturally have their packets flow through this device by the kernel.
So you assign an IP address and everything at the beginning, and then you just leave it there.
Absolutely. Okay. It just shows up as a regular Linux network interface. So none of the apps have to know that this happens to be backed by Connect IP. The other way of using it is when you're doing more direct flows yourself, which is where a lot of the IP protocol scoping and a whole bunch of other things happen, where, for example, if you have a user space stack which is already doing packetization, such as a quick stack, and you want to do some sort of interesting tunneling, you can use that mode directly, and you don't necessarily need a ton device. We implemented that as well, where we were going and doing fetches of example.com directly encapsulated through a mass connect IP stream. But that usually requires that your application is actually aware of that mode.
Oh yeah.
So it wouldn't be great for TCP. You would need to have like a user space TCP stack if you wanted to work that way. But this is by design. This is why we have Connect and Connect UDP as well.
I'm sort of wondering how. I guess in the second mode, the first mode, yeah, makes sense. I guess the second mode, I'm wondering, so like, do we have, for example, like, how do we know that anything using the BSD sockets API, that this protocol is expressive enough to support that? Do we have like an app that like a non-trivial app that was tried, like you tried to port it, right? Like you took all the instances of bind or connect and tried to, but I mean, it's just a question. Maybe you didn't do it and maybe that's okay.
Yeah, so the short answer is we didn't do exactly what you were suggesting, but we are running like a quick stack over that mode. And like it was fairly easy, at least on the Google implementation. I'm not sure on the Apple or Ericsson ones because I wasn't working on those, to go and have an encapsulated packet writer that went and did all the things without any sort of difficulty.
Thanks.
All right, Tommy, you're up.
All right, I think I'm next up. So just to the question here, I think, yeah, we could do last call on this. I think we could do it on the current version. I don't think we need another pass necessarily, and definitely agreed that doing int-area review in parallel would be good. One thing I wanted to mention here, just for the interop, was that this was also a really good opportunity to, I think, for the first time between a lot of these stacks, do a real capsule interop with non-trivial capsules back and forth. I know we already shipped the capsule protocol RFC, but at least I was not aware of this level of really using capsules in some of these protocols. So I think if for nothing else, doing the Connect IP work is a good way to exercise that and prove that that part of the stack works. And then to Lorenzo's question, I just wanted to mention, so the testing that we did from the Apple client was all the like per flow stuff, not the interface level VPN. So, we do have our kind of like quote unquote modern socket replacement APIs that have a user space IP stack. And so they could easily work with this directly. And then on Apple platforms, for BSD sockets, we've had a way to bridge those for quite a while as like an application level VPN and divert those over to a process that can do a modern proxying stack. So I don't know if Android has that, but we were able to test with those cases where you have a app that doesn't know anything about it and just opening up a socket.
David Skenazi, mask enthusiast. First off, Tommy, thank you for starting your day at 1:30 a.m. to be here. Really appreciate it. Some thoughts on this, Lorenzo. Well, first to Tommy's point, we had some non-trivial interop for capsules with web transport. So we had that before we shipped that RFC, and we kind of helped us establish that, at least in the Google implementation of Chrome and with some web transport servers, like Twitch, if I recall correctly. But anyway, having more is always better. Back to the Connect IP and the mapping to BSD APIs. The way I've been thinking about it is Connect IP fits into a suite. And if you look at the BSD API, which is, in practice what apps use, or, what the other more modern, better APIs like what Apple has, they, inherited the security properties of the BSD API, which is an app running on your phone can open a TCP socket, it can, or a TCP connection, it can open a UDP association, but it can't create completely a raw socket. And so the idea is, if you want to map that, which, for mask privacy proxies that we've been are looking at implementing, the idea is if the app wants to open a TCP socket, that gets mapped to connect, which has the very same semantics as TCP. And you can do that with a collaborating app where the app just calls an API that does that. Or you can do it in a non-collaborating app if you have kernel APIs that allow you to hook in at the flow level. So Android doesn't have those. Pretty please. That would be a great feature to have. Any Linux kernel hackers around? But Apple has a way where you just hijack the flow and you get the calls in user space directly from the socket. It doesn't involve the TCP stack at all, which is a great way to hook from a TCP socket of a an app that doesn't want to do this. You can just drag it kicking and screaming in a way that's really efficient because you don't have to involve the TCP stack at all. And same for UDP, you can use Connect UDP, and Connect IP is kind of the pan at the bottom to catch everything else. So if the app wants to do ICMP, for example, on BSD OSs, you can do ping as a non-root user. And there are, I'm sure, other use cases. Connect IP is for those. So that's kind of the way this all fits together, at least in my mind. And when you have a user space networking stack like Apple does, you can do that all inside that stack where you can swap out your TCP stack for your Connect machinery. Hope that helps.
Yeah, thank you. I actually tried to click the button to lower my hand, but it didn't work, so I'm still in the queue. So, but maybe you can boot me up. But I guess one sort of concrete question I'd ask is, for example, the BSD sockets API has a concept of being able to bind to a port, and it provides certain guarantees. Like, for example, unless you go out of your way to say that they can, no other app can bind to that port. So in the TON scenario, fine, that the kernel deals with all of that. You just, that the kernel stack will deal with that. But in the sort of more direct access scenario, I don't know what you call it, but, an app would be able to, sounds like it would be able to send their arbitrary IP diagrams, right? And then in that case, right, how do you provide a device, let's say the phone, with egress to the internet without how do apps collaborate? Do you need to give every different app its own IP address, for example, because you don't have, port mapping things? So
yeah, so there's a couple of different ways to do this. So one way to do this would be some additional extensions, which we have discussed in the past and haven't yet decided to do, to allow carving up the port range spaces. We basically decided in the design team, beginning of this year, I think it was the beginning of this year, that we were going to basically handle in Connect IP initially anything which is in the IP header and not anything which is in the TCP or UDP headers downstream. But it's totally possible to design an extension to allow carving up, for example, the port range, so you can say I can request IP proto TCP and then have it request port range 10,000 to 11,000. That doesn't exist today. That's definitely something that someone, if they were excited about it, could write up. The other way of doing it is, imagine you can do a link local IPv6 address and then NAT on the Connect IP proxy server.
I was worried you'd say that.
So you don't necessarily have to egress with the same IP which is assigned to the inside of the tunnel.
Yeah. Okay. No, that I understand that. One point to David, to your point. Much as I would like it to be different, the Android sort of kernel timelines are 7 to 10 years. It's depressing, but that's how it is. So in terms of getting a feature to the fleet. So yeah, I'm relying on that to deploy this is maybe not going to. But anyway, yeah. So anyways, that it sounds like the primary case was like either the ton case, which seems like well specified and basically functional at this point, and a sort of like a single tenant kind of thing where you give an app an IP address. And so for V6, you could have where you whatever 50 apps on the phone, and they could each have their own IP address, and they could use IP connectivity. For V4, yeah, I guess you wouldn't. I guess you could use that. Yeah. Okay. Anyway, thanks. That does clarify. It's sort of like kind of out of scope, right?
Yeah, the other thing I quickly like to add is to emphasize something that David said earlier, which is that Connect IP is like, the catch-all for when you want to do something that is not already handled by Connect or Connect UDP. We expect that 99% of the different use cases of an app wants to do something TCP related or UDP related, scope to a specific port, it's going to be handled by those existing specifications that we have.
So if I can write a WebRTC client with Connect UDP, I can bind.
Based on drafts that you have today, yes, you can bind to a specific port, I believe. I don't think we have listen yet, but I think that's actually on the agenda for this week.
Okay. Thanks.
All right. I see, Miria, you are asking for slides. Ah, I will decline that request then. Cool. All right, so it sounds like we're going to spend a couple of weeks doing a quick editorial pass, and then we will go for working group last call, as well as requesting interior review in parallel. Wonderful. Thank you so much.
Thank you so much.
All right, next up we have proxying listener UDP. And there we are.
All right. Hi, everyone. My name is Abhi Singh, Google, and I'll be presenting the Connect UDP listener today. So since our last presentation at IETF115, we've made a few changes, but most of them are editorial ones. Next slide, please. So what Connect UDP is right now is it enables connected UDP sockets. So the proxy can send and receive from a single target specified in the path field of the connect header. But what if we wanted more tuples? Next slide, please. Take, for example, WebRTC. Like in this basic topology, the clients are pinging a stun server. Next slide, please. And then a peer-to-peer connection is established here between Bob and Alice, so they can have a very important discussion about their favorite cat videos. Next slide, please. So the same topology with the proxy would look something like this. Next slide, please. And in an ideal world, hopefully the proxy would relay the discussion about the cat videos to Alice. Next slide, please. Now, the question is, why not just use multiple Connect UDP connections? That could work, right? That could help us get multiple 5 tuples. Next slide, please. Now here's the catch. Because we're running HTTP proxies, 2 individual requests, they aren't guaranteed to be served by the same server instance. So the IPs that get exposed at the end of the proxy might be different. And so this breaks ice. So if this sounds familiar, it's kind of like what we have with like symmetric NATs, but I think like using turn servers to support this seems very unnecessary and expensive when we could still support peer-to-peer. Next slide, please. So presenting Connect UDP now with listener support. And so one Connect UDP connection, infinitely as many UDP targets. Next slide, please. So how does it work? I mean, so in the header, as you can see, like we specify the paths with asterisks, meaning we can have as many targets as we like. And so in the quick frame, you'll see there's a connect UDP listen section with the IP address. Next slide, please. So what this IP field is, so when the connect UDP datagrams are sent from the client to the proxy, they represent the target IPR port that it should be forwarded to. Whereas in the other direction, when the proxy is receiving and sending it back to the client, it would represent the source IP from which the proxy received these packets. But here there's an open question, like, does the proxy validate source packets? And I guess this is where we would need like people who have expertise with WebRTC Turn. Next slide, please. So I would like to open the question, like, are we interested in adoption? Of course, we'll need some security considerations, like I mentioned. Like anyone who has like WebRTC or Turn expertise, that would be quite helpful. Next slide, please. And that would be it. So we can open the mic for some questions.
Wonderful. All right, our queue is currently booting, but Lorenzo is first. Lorenzo is no longer first. It does work. All right. Keep walking, Lorenzo. So we have a timer on screen. We're going to try to keep our comments within that time. So the two things that we want to talk about are, one, technical feedback, clarifying questions, anything like that, as long as we keep it super short. And the other is this the kind of thing that we'd like to include in our charter? Is this useful? Is this necessary for real world deployments? That kind of thing. All right, Lorenzo.
Well, I guess Tommy was before me, but is this useful? I think it's necessary if you want to do anything, more complicated than just a client-server interaction. So it does seem useful. From a technical feedback perspective, usually apps will bind to an empty address, and so that's one thing to consider. And there, again, like to my earlier point about mapping this to sockets API, is they do things like bind, connect, and then call get sock name to figure out what their local address is, and so on. So those are sort of like things that they're accustomed to doing, that if you want to port an app to use this, such as WebRTC, you might want to think about those semantics and replicating them a little bit. Things like get sock name are actually, and get peer name are often used. The other thing that I would say also is a complexity that you need to think about is the dual stack sockets. So often an app won't know if a connection is coming in on v4 or v6, and it'll just like bind to a v6 address, AFI 6 empty, and then it will, the kernel will deal with v4 traffic on that socket using mapped addresses and so on. That's you can make all that work, and I think yeah, okay, so it does, yeah, and that's something that's like sometimes untrivial, but good to know that you've already implemented it.
Awesome.
All right, Tommy.
All right. Hello. So yes, this is definitely useful. I would say this is the main pain point for the browser use case when using a mask proxy. And we've been running with it and deploying these for like 2 years now. And this is kind of like the main gap that we need to fill. So please, let's do it. Let's adopt it here. I also think if anything is in scope for this group, this should be, because this is kind of like a clear like bug fix essentially in the whole Connect UDP ecosystem.
Mm-hmm.
The one other thing I would leave is doing something like this for Connect TCP would be interesting too. I know that shouldn't be this document, but that should also be addressed.
Alessandro Gadini, Cloudflare. I don't have any comments specifically on the draft, but I do think that the use case is important, so we should work on it.
Awesome.
Okay, it's Kanazi. Thanks, Abi, for waking up at 4:30 a.m. and joining us today. This time zone is rough for the US this time around. Just wanted to answer Lorenzo's question as co-author. The kind of spiritual, or that's not the right word, the conceptual way to think about this is, so Connect UDP unextended, the current version that's published, is a connected UDP socket, and this is a non-connected UDP socket. So you do bind, and then you get on every packet that comes in the receive packet info, and then you can send to a bunch of places. So like get peer name, it's not, because it's not connected there, and the call for getting your local name, like that's the one that's like not defined. But if you wanted to fit that, you would say here's a 1918 space address that's fake, because that address doesn't exist in this space. It's like, imagine, like, I'm realizing the more and more we think about this, more and more masks feels like a NAT that's running over HTTP, which is kind of ironic because the old name for NAT was Masquerade. But that's kind of what this is, where like if you can give your app an address, but it'll be fake just as an address that's private to your side of the NAT is fake. One thing that folks have talked about that we can decide if we want it to be in this draft or not is you could also add an option to use mask to say, hey, here's the public address that the proxy is using for this connection on the outside, in case that's useful to facilitate things like ICE and all that. Yeah. Yeah. So that could be a useful, I wouldn't say you need it, because with a NAT, like you don't have that. You don't have a way to tell the NAT what's my public address today, and things still work, because like with Stun, you can do that. But it sounds like a useful feature. Maybe we can use that. But I think it fits into the shape of what you're describing. Yeah. No, for sure. It's just a way to think about it. I hate NATs as much as the next person.
All right. Thank you very much. Sounds like we've got quite a bit of interest. Let's move on to our next topic.
Eric, before we move on, just
Yes.
asking as a co-author, what are our next steps here? Should we talk about adoption, or is this a conversation we will have after the recharter?
We're going to talk about that after the recharter, because we have the whole pile of documents.
Perfect.
And one of the questions is, where do we draw that line?
Thanks.
So adoption is on the table for anything that we decide to charter. All right, next up, we have quick aware proxying using HTTP.
Hello, can you hear me all right?
We can hear you and see you.
Awesome. I'm Eric Rosenberg, Apple. I'm going to be talking about quick aware proxying using HTTP, which is an extension to Connect UDP when Quick is being proxied. Next slide, please. So why quick awareness? We already have Connect UDP, Quick runs over UDP, and everything's great. And everything is great, but there's some opportunities to try to make it better. One of the first things that you might come across when using Connect UDP is that if you're supporting target servers accessible over IPv4, you may run into port exhaustion between your proxy and the target. Additionally, when using Connect UDP, you may notice that there's MTU loss for each proxy that you use by encapsulating inside of HTTP datagrams. And this may not be a big deal when using a single Connect UDP proxy, but if you start to chain these proxies, this MTU loss can be quite consequential, even to the point of maybe not being able to run Quick over those nested tunnels. And then finally, there's the processing and send and receive overhead associated with Connect UDP that you would expect. And there are some opportunities to short circuit some of that work when you know that Quick is being proxied. Next slide, please. So what is quick aware proxying? Well, essentially, the client who is speaking quick to some target is able to tell the proxy some information about the quick connection that's being proxied. And specifically, the client is sharing the connection IDs for the inner quick connection with the proxy using the capsule protocol. And immediately with that information, what the proxy is able to do right off the bat is it's able to reuse target-facing ports for these Connect UDP tunnels. So instead of having to create a new unique socket that might be a new port for each Connect UDP request, if it knows that it's quick, it may be able to reuse sockets and distinguish traffic based on connection ID. On top of that, if a client and proxy agree that they want to support a forwarded mode of proxying, they may skip the encapsulation of the quick packet for the inner quick connection inside of an HTTP datagram for short header packets. And this is what we call forwarded mode, where the client is generating a quick packet for the client target quick connection. And instead of encapsulating it inside of an HTTP datagram, it can send it directly to the proxy over UDP. And using this forwarding mode helps eliminate the MTU loss associated with encapsulation. And one other thing to note about this forwarding mode is that the connection ID bytes on the wire between the client and the proxy are different than the connection ID bytes on the wire between the proxy and the target. And I'll explain more about that and why it's necessary in a moment. Next slide, please. So I introduced a little bit about how the client shares connection IDs with the proxy, and it's fairly straightforward how the proxy might be able to take advantage of that for port reuse. But forwarded mode requires a little more consideration. So before getting into too much more detail about that, when is this actually interesting? Well, as I said before, if this MTU loss makes a difference to you, if you're interested in chaining proxies, forwarded mode might be applicable. And it's also worth noting that when using forwarded mode, we're not encapsulating inside of an HTTP datagram. And so the quick packet contents that are on the wire between the client and the proxy and the target are largely identical. And so this is not preventing traffic analysis by observers of both sides of the proxy. Next slide, please. So consider we have a client on the left here who sends a Connect UDP request to a proxy. And under normal circumstances, the client trying to establish a quick connection with the target would use HTTP datagrams. With quick aware proxying, the client would also share connection ID information with the proxy using the capsule protocol. And once there was enough information, excuse me, the proxy could use that to reuse ports between it and the target. And if the client and proxy both agreed to support the forwarded mode, the client would be able to generate quick packets for the client target quick connection. And instead of encapsulating them inside of HTTP datagrams, if they were short header packets, they could send them directly to the proxy over UDP, where the proxy would then forward them on to the target, and similarly in the reverse direction. Next slide, please. So I mentioned virtual connection IDs without getting into much detail about it. Virtual connection IDs are a way of having the connection ID bytes on the wire between the client and proxy be different from the connection ID bytes on the wire between the proxy and target. And it may not be obvious why this is useful, but if we for a moment consider if we didn't have virtual connection IDs, if the packet between the client and proxy were identical to the packet between the proxy and the target, The proxy receiving these forwarding mode packets would be receiving quick packets that have connection ID bytes that it did not choose. And if that proxy were sitting behind some load balancer or other routing infrastructure that depends on being able to encode routing information in these connection ID bytes, it may not arrive on the right server. And so by introducing virtual connection IDs, we have an opportunity for the proxy to choose the connection ID bytes for quick packets that it receives on this forwarding mode. The proxy then translates or replaces that virtual connection ID with the real connection ID before forwarding it on to the target. Another good example of where virtual connection IDs are useful is connection migration. So assume that we have a client that is migrating its network path with the proxy. Depending on whether or not the target's interested in issuing more connection IDs and cooperating with using new connection IDs, the client may wish to migrate and also have those forwarded mode packet connection ID bytes change as the network path changes. And so by introducing virtual connection IDs, we're able to change the connection ID bytes on the wire independent of any change with the real connection ID. Next slide, please. So we've run the kind of regular Connect UDP implementation that we have, as well as our quick aware Connect UDP implementation in our lab. And there's certainly, I expect that quick implementations are going to mature, and this is our tunneling implementation is only going to get better. But what we've seen so far is that when we leverage quick aware forwarding, forwarding of these quick packets essentially requires an insignificant amount of CPU. So it's an extremely efficient thing to do. And it's a very lightweight way of proxying quick. Next slide, please. So I mentioned earlier that we're using the capsule protocol. There are about 6 capsule types that are part of this exchange. I could come back to this slide about the details of each, but it might be more interesting to jump to a sequence diagram where they're actually used. So next slide, please. Okay, so consider that we have a client. It's sending a Connect UDP request. It's indicating that it wants to do this forwarding mode, which is optional. The client is also telling the proxy about the client's connection ID in the form of a capsule. And it's also sending its client initial inside of an HTTP datagram, all in the same flight. The proxy then takes that information, optionally reuses ports. And if it also supports forwarding mode, it can go ahead and create a forwarding rule in the target to client direction. The proxy sends the client's quick initial to the target. It sends a 200 status code to the client, including that it does support forwarding mode, acknowledging that it received the client's connection ID. After receiving the server's quick initial, it encapsulates that inside of an HTTP datagram because long header packets are always encapsulated to avoid unnecessary exposure. Now that the client knows the target's connection ID, it shares that with the proxy, and we're able to complete the set of forwarding rules. So now we have a forwarding rule in both directions, target to client, client to target. And after acknowledging the receipt of this target connection ID information, the client is able to use this forwarding mode where it generates a quick packet for the client target quick connection. It, instead of encapsulating that inside of an HTTP datagram, it replaces the connection ID bytes with the virtual target connection ID bytes, sends it over UDP to the proxy. The proxy recognizes these connection ID bytes in the packet, replaces the virtual target connection ID with the real target connection ID before forwarding it on to the target, and similarly in the reverse direction. Next slide, please. So that is quick aware proxying using HTTP. Very interested in folks reviewing the draft and providing some feedback and gauging interest from the working group. Thank you.
Martin Duke, Google, no hats for this comment. Thanks for this. First one, a clarifying question, which quiche?
Oh yes, this is Cloudflare, based on Cloudflare's quiche.
Okay. So I think the use case for this is pretty clear, but having thought about this way too long the other day, I'm concerned there's some foot guns that we need to work through. One is, first of all, the virtual CID thing is like a great idea. I'm wondering if it's correct to bind those one-to-one to the real CIDs. I'm having a lot of trouble reasoning about the threat model of like linkability versus like the proxy anonymity of if you're, I mean, clearly you need to change the virtual CIDs on the proxy between the proxy and the client, but do you actually want to change the CID that comes out of the proxy to the target? And I think the answer is no, but that might be wrong. Similarly, and I think I brought this up on GitHub, but the interesting property I realized about this is that if the proxy client connection consists entirely of these sorts of forwarding mode things, that you can essentially have no ACK feedback on the mask connection, which is a very weird situation for transport. There's an idle time issue, which people have thought about, but there's other things like a lot of congestion controllers will like kill their congestion window after a while if they don't get, if it's allegedly idle, etc. And so I would, one nice thing about this being the transport area is like maybe some of the right people here are to think about that really hard and make sure we eliminate a lot of those foot guns, at least with some advisory text, but just thinking if there's something more we need to do here. Some way to like collect the acts of these. Well, you can't act them because they have no packet number. So it's another way of thinking of it is sort of just this is a way of negotiating a layer 3 tunnel or a layer 3 forwarding situation, which maybe makes it okay. But I have a little bit of the willies about all these sorts of concerns. Thanks.
Yeah, thank you. Just to address the first comment, I don't think that the virtual connection ID and the real connection ID have to be one-to-one. And we still need to kind of flesh out the details of the protocol, but the idea is that the virtual connection ID can change and still be mapped to the same real connection ID. And then, yes, for accommodating for there not being traffic on the regular client to proxy connection, thus far we've been leveraging Keep Lives to keep that stream alive.
Yeah, right. That's fine. I fear that there's a problem beyond Keep Alives, but I can't articulate it very well right now. Thank you.
Yep, thanks.
Mike Bishop, Akamai. I think this is an important problem to solve. I think this draft is a very elegant way of doing it, even if there are some details to be worked out. Also, in the real world, often you're not using this just for one connection that you set up a tunnel and then never touch the control channel again. You're usually also still using it for other traffic, for other connections that are coming and going at the same time. So yeah, there's some stuff to work out with certain usage patterns, but that's something we could do post-adoption. I think this should be in scope for a returner.
Alessandro Ghedini, Cloudflare. I agree, like this has clear benefits, so it's something we should work on. I do have a question about virtual CIDs, and I think this is maybe something we discussed in the past, but I understand how, like, you described how that works between the client and the proxy, but I think we would have the same problem between, the target and the proxy and having to route packets based on proxy chosen CID. Again, between the target and the proxy. So I was wondering if the existing mechanism that you described would also solve that problem, or if it's something that we would need to add later on.
Yeah, thank you. I think I'd have to understand a little bit more about exactly what you're talking about. There are virtual connection IDs in both directions, one that the proxy chooses and one that the client chooses. And it's the receiver that's deciding, and the receiver in this case is the client. So from packets that are coming from the target to the proxy, for now have the real connection ID to make sure that we don't require any cooperation from the target.
So the real connection ID being the connection ID picked by the client.
Yes.
Right. So I think the problem being in a situation where you require routing quick packets based on connection ID, the proxy would have to have a say in what the connection ID is in the case.
Thanks.
Hey, Lucas Pardew, Cloudflare. I think this is a clear use case for this. It's got clear benefits. It's not just a micro optimization. There's like some strong properties that it can provide. The technical details, yeah, we need to hammer out some of the edge cases or foot guns here. Earlier draft didn't quite fit the needs of like Alessandro just alluded to, load balancing concerns. The later draft with virtual SIDs is a much clearer path. To echo Mike's point, I think there's ways we can mitigate stuff via control channels or other stuff. Like we should do this work here, I think, so that we can actually get collective view of different deployments, like same technology, different deployments, different concerns. Let's try and come up with technical solutions to this. So thanks for doing the work. And I'm always happy to review and give feedback.
Thanks.
Martin Thompson, this is in on. All right. Pardon me. Yeah, it got short. The thing that bothers me about this design, aside from all of the questions that Alessandro had, which I also agree with, I'm just going to keep going, is that traffic analysis here is trivial. And I think what this design really needs is re-encryption at the proxy as well in both directions. I realize that's unfortunate and maybe less efficient, but the privacy properties of the protocol are not that great until you do that. So I'd like to at least consider that. Yeah, I think Eka's raised this point in the past. It's just concretely not biting. So I will continue. Eka's raised this point before. I think he raised it in terms of saying, what's your threat model? Which is a nice way of saying, I don't like this design. So please consider that. It's just really broken.
Thanks.
Sorry, this microphone stand is impaired. David Skenazy, Ask Enthusiast. So unsurprisingly, I think, like, yeah, I agree with people. There's a need for this. It really solves something. There are a lot of details to hammer out, but yeah, this working group seems like the right place to do that. So +1 to recharting the working group in such a way that this fits in, and then adopting this. I think Martin and Eric are operating with different threat models, which is fine. So we might need, multiple modes of operation. One of the really nice properties, if you don't re-encrypt, is that it allows you to implement the forwarding mode in eBPF fully on the NIC without ever touching the CPU, which is pretty banana pants awesome. And so I think Eric has done that, which is crazy awesome. Great work. And I think for some use cases, that's what, that makes a huge difference and allows you to scale way more. And for other use cases that Martin has, maybe we don't. So maybe we have another mode where we do re-encrypt, which are both valid things. So we'll have to talk about that more, but I think the working group is the right place for this.
Thank you.
Wonderful. Thank you very much. We're at time for this presentation, but it again sounds like we've got a good bit of interest and people think that this is a valuable problem to solve, and this working group is probably the right place to solve it. Next up, we have access service description objects.
Okay. Hello, everybody. This is Ben Schwartz from Alphabet, I guess. And this is, I changed the title to Access Service Description URI. Okay. So what am I talking about? What is an access service? I came up with some kind of definition for what I mean by this. Basically, it's a thing you use to access the internet using HTTP. I mean, these things. We have all these things now in HTTP that allow you to access the internet over HTTP. And so this presentation is about, this draft is about, how do I turn it on? So here's the status quo of how you choose your proxy server. You put in an FTP proxy or something. And this is how you configure a VPN server. So I guess if we want to activate Connect IP, it goes in here maybe. And this is how you choose your DO server. I wrote some of this code. So this is the status quo. And so how many different times are we going to ask users to enter the config information? How many different times does the user need to authenticate? This connects to something I heard David Skenazy say a few minutes ago, that that it's easy to imagine services where there's a UDP proxy service, there's an IP proxy service, maybe there are other proxy services, and any given connection uses one of them as appropriate based on how that app happens to be implemented, based on what transport protocol it's using. So this is sort of based on an idea that from the user's perspective, this whole bundle is really one service. The user's mental model is that this is an access service or a proxy service or a VPN service. So that's one problem. And the other problem is authentication. How many times does the user need to authenticate to all of these different services? These are different HTTP endpoints. There's no, potentially even on different origins. There's no necessary rule that they all need to be authenticated in the same way. So the goal of this draft is to enable a world where the user just enters one magic string, a URI, into one user interface somewhere to activate this thing, this access service, and the users authenticate to that once, and that's all they need to worry about. So here's a very detailed rundown of how this all would work. But basically, there's a URL. The user has the URL. They plop it into some user interface, and then the client fetches it. Periodically when it expires, it fetches it again, and the thing it gets back tells it all the different services, sub-services that are available. And crucially, the authentication is done on the access service description URL, and then that authentication information transfers to all these different services, so we don't need to authenticate them separately. So what's at this URL? The exact format doesn't matter, but you could call this a placeholder, but fundamentally it's just a trivial structure containing the templates for all these different things. Some of you may note that in addition to the connect UDP, connect IP, and DO templates here, there's also some other stuff for TCP and HTTP. I have 5 minutes maybe at the end of the session to talk about that. So that would be like a connect TCP thing if we wanted to do that. So this sort of imagines a world where we've fully transitioned to this kind of template-driven description of proxies, and so we have this nice parallel construction where all of our different protocols are described the same way. So this was, I presented this at the last session, but a bunch of things have changed here. So there's those template-driven TCP proxies and such. And I removed any normative mention of oblivious HTTP from this, which previously some oblivious HTTP stuff was mixed in here. It seemed like that was not popular. So now instead of having key configs in here, none of that, the key configs can be described by some other object that Tommy Polly has a draft for. And I added this discussion of authentication, which I hadn't been talking about yet. I want to highlight that what I really think would be even more interesting here, it's not in the draft, is a vanity URI scheme for this. So you just replace HTTPS : with mask : and now you can imagine saying, okay, how do I activate an access service for my device? You just click on a mask : hyperlink, and this is very dangerous. But it's very powerful, and basically I have faith that the very small number of implementers who actually have to think about this, because it's only basically operating systems and browsers, would think very carefully and maybe not support it, but if they did support it, would put up suitable barriers to make it safe. So that's my very simple proposal, and I'd like to see this adopted in Mask, presumably after some kind of rechartering discussion. I think that's it. Eric?
Yeah, overall, I like this. I want to see it happen somewhere, at least something along these lines, but I'm not completely convinced this fits for potential recharter in this group. I skimmed into preview discussion we're going to have there at the end of this meeting, but assuming the plan is we want to recharter this group to be focused tightly to wind down after finishing up the necessary work, then I think we should leave this group focused on proxying UDP and IP and similar stuff around this. And this proposal is more of just a general proxying thing. So if we recharter a lot of stuff like this, we're taking the big risk of rechartering this working group into becoming just a general proxying working group. And I'm kind of afraid that's too much scope. That's the plan that will lead to this be a permanent working group. And I don't know if that's the greatest idea. So I want this to happen. Maybe something like HTTP working group would be a better place. I'm not completely sure, but my suggestion is maybe we don't recharter to allow this, and this doesn't meet the bar for a recharter this working. But still, please make this happen somewhere.
Okay. I don't really have an opinion about venue. Tommy?
All right. So thank you for updating this. I do think this is better and clearer than the previous proposal. I'm still on the fence about the exact details here. And like when I imagine in like the short term how the configuration is going to work for these types of things, I see two kind of main paths for configuring. Like one, kind of like you were alluding to, we have these legacy proxy configuration boxes somewhere in an OS or browser settings UI. And in those cases, the user just like types in a name of something. For those cases, Connect works already. And for Connect UDP, Connect IP, we defined a well-known URI specifically so that we could just try those and have a well-known location off of a name. So that case seems to have a short-term solution that works okay. And then the other model is, we could either have a application or we have like MDM profiles, like you could have a more complex language for describing all of your different URLs that could come in some other format. So I think what you have here definitely enables more automatic use cases, but I think I'd want to see more, and I think it just requires more discussion among this group or another group more broadly to understand like what's the exact kind of user flow and who's going to need to get this information that can't either get it from a well-known URI or can't have a richer configuration profile described in another way.
Thanks. Alex?
Hi, hi, Alex Chernohovsky, Google. Ben, I think this is very cool, and I think you're onto something here. But I think I still would like to better understand what the user story here is, because one of the things that I'm having a hard time wrapping my head around is how we envision people using this, and I think that would really inform the specific design, which sort of leads me to say that I'm not sure that we're necessarily the right group here. And then second, the messages in the Zulip of taking this to dispatch. But I think definitely we need to better understand how we envision users using this. I can't personally think of the last time I used the proxy UI to configure something other than when I was developing. So I'm not sure if the solution and the problem quite match up yet.
Yeah, I'll say, we don't really use these UIs. They exist, but like, I think the vastly more people install VPN apps from their app store than use these like IPsec configuration UIs that every platform carries. And I think that's a bad thing. I think that that's a failure of standardization, and we should be trying to define standards so that we don't have separate apps for all of these things that when we can standardize it end to end.
Yeah. Martin Thompson, I suggested dispatch. I think there's a really difficult question here about scope. You've talked about DOE, you've talked about OHI, you've talked about a bunch of other things. If I imagine all of those things falling under this umbrella, there's an interesting sort of question that a very concerned internet citizen might ask about, in the interest of users, about centralization.
Thanks. I don't actually see a significant centralization concern here. I think that these, if anything, this makes it a lot easier to spin up new competing access services by lowering the barrier to creating new ones. Right now, the barrier, the amount of technical work required to get started is much more significant.
Yeah, the reason I said that is that in your description you had one UI affordance and one authentication, and that's the sort of thing that bothers me when it comes to these sorts of diversity of services.
David Skenazy, I think there's something here, like there's something in this space. I agree that like it's not 100% clear to me like what the UI flow is and kind of what the boundary is of this is. So like how many things do we have in here? And that points a question to scope. So I think I want to see this work happen to, or at least get a little bit further down the road to like really understand where we're going with it. But I'll plus one previous comments that maybe like MASQUE itself is not the right place because it touches DOE and probably OHI and a lot of other things.
Wonderful. Thank you very much, Ben. It sounds like there is interest in seeing this go forwards in some form somewhere, but potentially we need to look for a dispatch or something like that. Next up, we have HTTP proxy status parameters.
All right. Hello, everyone. So this is a pretty minor little addition, and it's this one straddles the boundary between MASQUE and just generic HTTP for proxies. But sharing it here because it really has to do with this forward proxying, privacy proxying use case. All right, so first some background. We're talking about a addition to proxy status. So what is proxy status? This is defined in a recent RFC 9209. It's a new header field that lets proxies tell clients extra information in their responses. It includes the a list of identifiers of the different proxies that handle the given request. That's not super interesting for this, but it also includes an extensible list of parameters that can include errors and upstream details, etc. So why is this relevant for MASQUE? I don't think we've talked about it in this group, but in practicality, it is very, very useful for Connect UDP, and Connect IP proxies. It's also useful for reverse proxies too. And in the case where we are currently using MASQUE for private relay, we use this status all the time, for example, to communicate DNS failures or that you had an unreachable IP. And this lets the client determine what errors to show or what policy to apply as far as saying, oh, maybe this is a local network resource. So as an example, you may get back a proxy status that says, hey, your example proxy hit a DNS error and that error was NX domain. And so now you know that you were trying to reach a domain that doesn't really exist, at least on the public DNS. So to see how that works out, clients doing connect UDP to an or connect UDP to a bad.example.com, the proxy will try to resolve that, gets NX domain, says, hey, sorry, 502, here's the error. So that works fine. Okay, so what is missing? What's the problem that we're trying to solve? So in the successful cases for being able to actually connect to a server over the proxy and actually having DNS work, there isn't a parameter to communicate any DNS response details. There is a next hop parameter, which can contain one token, which is a name or an IP address or an alias. But that's not really the same as saying you have DNS response details. And why would you want DNS response details? So there are many different reasons, but the one I'm concerned about here is the fact that clients can use DNS responses, including like a CNAME chain, as well as the resulting IP address that you connect to detect CNAME cloaking or IP cloaking. So this is a case where I'm going to what looks like a benign domain, but it's actually being CNAMEd to a name that maybe I want to apply special policy towards because it is a endpoint that is doing a lot of tracking or data collection, or is something that the user wants to block for some other reason or wants to apply some policy to. Or it even may be a case where instead of using a CNAME, it is directly going to an IP address that is a known tracking endpoint or some other concerning IP address that we want to be able to apply policy towards. And you could solve this by having clients always do their own DNS lookups before they use the proxy, or do DO or something else through the proxy itself. But that definitely is a lot less performant than what we're able to do with a normal connect or connect UDP. And it's not, I think, a good trade-off to say that in order to be able to apply CNAME cloaking prevention or IP cloaking preventions, that you need to lose a lot of the performance wins that make going through a proxy viable for a browser use case. So to go back to the use case here, if we have a successful connect, for example, to example.com, the proxy itself is doing a resolution. It knows if there is a CNAME there, it knows what the IP address is. The client does not learn that, however. It just gets back a 200 OK proxy status that can include, for example, the next hop, and that's just the name that we originally requested. So the concerning case is, let's say this is CNAME or IP cloaking, and I'm happily going to example.com, but now it's being CNAMEd to tracker.example, and it has an IP address that is somehow concerning to me, potentially. And that response looks exactly the same. I cannot tell what's going on there. So the proposal is very, very simple. It's just to add one new parameter, currently calling it DNS used, and that is essentially the DNS answer and chain of aliases that was used to create this connection. And so a client would be able to read this and apply whatever policy it has. In the browser, this is going to be about preventing cookie sharing or potentially blocking a resource. And the proxy status parameter for DNS use is very simple. It would just be a string that is a list of the IP address and any aliases or CNAMEs that were on that chain. So this particular proposal is very limited and very minimal. It's intentionally that way to be very simple to add. Proxies can add this with whatever information they have. It doesn't require any extra negotiation, and it's just extra useful information. And it solves a real problem that we have for our browser. And I think when we discussed this on list, other people mentioned that they would have use for similar information. I also want to point out there's definitely room for more work and thought about DNS results over a proxy. This does not address how would you do DNSSEC validation over a proxy? How would you get SVCB parameters if you want to do ECH or ALPN negotiation? Those cases require more active work on a proxy to say, please also request these things and give me the responses. And we would want more complicated negotiation. Maybe we could use capsules for those. Maybe there are other headers, etc. So I think there's work to do in that area, but I would encourage us to split up the different problems. And I think we can have incremental usefulness with a parameter like DNS used. So questions, do we think this is useful? Where should it be? It could go either in MASQUE or HTTP. I think both groups should have review and input on it. And also this is a call to, if people want to talk about more advanced proxying DNS use cases, we should talk about that.
David Skenazy. Thanks, Tommy. I think this is useful. And I think the space of more information about the DNS through an HTTP proxy makes a lot of sense. So I want to see things like this happen. In terms of where to do the work, my gut feeling is this applies to more than MASQUE. It makes sense for other HTTP things. So perhaps it makes more sense in HTTP BIS, but not horribly strongly on that one.
Yeah, Martin Thompson, this seems like an extraordinarily narrow solution to a very specific problem where we know that we have a more general problem sitting right there. You pointed out in the last slide. I would prefer to explore those other solutions before deciding to do the narrow thing. I think there's too many cases where the client needs more information about what was done in terms of the DNS queries, that maybe the right place to do this work is ADD instead.
Sure. Yeah, I definitely agree that we should do the bigger stuff too. But yeah, I do think there is incremental value for doing the small thing. It's a useful hint anyway. All right, Ben.
Hi, Ben Schwartz. I don't know that I believe in the CNAME cloaking use case really, but I do want this just to be to Lorenzo's point about supporting the POSIX APIs. This is very useful if you're trying to emulate GetAdder info, which does surface the CNAME results, at least optionally. So just for the sake of being able to implement getAttr info, I think this is useful. I see this as quite distinct from a deeper system for conveying DNS results generally, which is a much bigger problem and runs into a lot of DNS ossification questions. And please change the name. DNS used is not good enough. Let's do better.
Sure. Do you have a suggestion? Oh, sorry, you're gone. Drop me a suggestion somewhere.
My suggestion is something involving the word CNAME.
Okay. It includes an IP address too. So, Maria?
Yeah, I'm not sure about where this specific solution belongs, if it's in this group or in another group, but I think we should actually take the DNS use cases in scope for the rechartering, because I think there might be more work in this space that we should not ignore.
Excellent. All right. Thank you very much. And we're going to speed round through 3 more quick things. So everybody take a moment to breathe in, breathe out, stretch a little bit. And then we will talk about some rechartering. So next up, we have sequence numbers. Marcus.
All right. Hello, hello. So I'm going to talk about very, very small proposed extensions about adding numbers to HTTP datagrams. So next slide, please. So some background why we want to do this. 3GPP are working on a study called ATSSS. It's a study on access traffic steering, switching, and splitting, supporting the 5G system architecture. So it's basically solutions for steering traffic across 3GPP and non-3GPP accesses. There are various ways of doing that. Different steering modes. One of these steering modes is called traffic splitting, where you basically do bandwidth aggregation. There are already solutions defined in release 16 of 3GPP where MPTCP is used. Now we're looking at other solutions for non-TCP traffic, and there have been various proposals for how to do the multipath steering. And MP-Quick has been decided as one of the potential solutions, and that could be used together with MASQUE. Now, these ATSSS endpoints, when you're splitting traffic, they would like to be able to support limited reordering of the received packets to be able to compensate for path delay differences of the different accesses. So when we use Quick, we can either send data as streams or as in datagrams. The problem is when you send data in streams, you get full reordering, you get a lot of delay jitter, you need to handle retransmissions and whatnot. If you send data as pure Quick datagrams, you get no reordering at all. You get a lot of out of order delivery of packets. You get a lot of potential duplicate acknowledgements, and things like this also have problems with performance. So to be able to do like some partial reordering, the ATSS study proposes to extend HTTP datagrams with a sequence number so that you can perform limited reordering based on the differences between the path delays. Next slide, please. So it's a very simple extension to MASQUE that is being proposed. We just add a new type of a payload format. So we have a sequence number datagram that has a sequence number followed by some payload. Next slide, please. To indicate support for this, we're proposing to use a capsule. First, you can indicate support using a HTTP header. Then you can register the use of sequence numbers for your datagrams by sending a capsule. The capsule would indicate the size of the sequence number used, a context ID, and also indicate what payload format there is of the inner payload. And if you have multiple inner payload formats, like you can have UDP payload, or in Connect IP, we might have IP payload as the normal inner payload, but we might have other extensions coming up with compression of IP and such, so you might have multiple context IDs existing in parallel. We're also looking at how you can register new context IDs for sequence number datagrams that would wrap different types of inner payload formats. And this is what we're proposing. We're proposing to use 2 different kinds of capsules for this. One to register the use of a sequence, packet sequence, and another one to basically register context ID aliases for the same packet sequence so that we can support multiple inner payload formats. And this is pretty much it, what we're proposing. And we would wonder if this is something that is in scope for this group or for some other group, or if 3GPP should work on it by themselves. Corey.
Very quick clarification. You said will use MP quick or might use MP quick, just for clarity.
Well, there has been quite some discussion, and to my knowledge, there's an agreement that MP quick will be used, but it's not agreed that it might be the only solution. There's also MPDCCP considered, and I'm not fully up to date with the latest. And I think there's a meeting next week that will clarify even more.
David Skenazy, thanks for presenting this. I'm still not convinced that this is a good idea. The concept itself of partial reordering on the proxy, because this starts to smell like a TCP accelerator, and those have been great for ossification and making performance worse. I have numbers for that one. So on that, I'm not sure it's good. To answer your specific question of if we want to do this, or if this is happening, where should it happen? I personally believe it should absolutely not happen in the 3GPP, and we shouldn't not encourage them to run with scissors, because that's how you can hurt yourself. So this topic is in scope for MASQUE. It's an extension to a document that we published in MASQUE, but I'm not sure we should necessarily progress this forward because I'm not sure it's a good idea. But like, I would be down to have that conversation in MASQUE.
Yep, that's great.
Hello, Han from Huawei. I think it's actually a good idea to do reordering in the proxy to help the endpoint have some kind of weak endpoint. Yeah, but there is a whole lot of discussion regarding the protocol ossification, that kind of stuff. Yeah, so I think we need to find a middle ground for the function between the proxy and the endpoint. Yeah.
Kazuho, so if I recall correctly, it has been an intentional choice within the quick working group to not expose the sequence number of packets being sent. And that was based on the understanding that exposing that would actually decrease the performance of a multi-stream transport protocol that doesn't always have the head of line blocking problem. So I think that this proposal is, the concern here would be that this proposal is actually negating the achievement that we made in the quick protocol. And I think that's a major concern.
Okay.
Yeah. All right. Thank you very much. Next up, we have HTTP datagrams, UDP proxying, and extensible prioritization from Lucas. Five-ish.
Good morning. I did not know how long I'd get for this slide, so I got loads of slides. Sorry, this talk. So let's go. This is a kind of a document I came up with about a year ago. I think I presented to this group. I can't quite remember. It's kind of just sat in the background. I've not been doing that much with it. I gave it a little spruce up about 4 months ago and kept things quiet, maybe trying to do some chatting in the hallways, and then I got ill and couldn't do it. So let's go with some background very briefly. We've got RFC 9000 quick, saying that stream multiplexing has a significant effect on application performance, but quick doesn't provide a mechanism providing for exchanging any prioritization information. So, your implementation is probably going to do some stuff if it cares about doing this application performance. Maybe it doesn't matter. But the signaling of what's important, what's not, is kind of punted. So HB3 is an application protocol. It could have had signals for stream prioritization, but we had some issues during that process, so we punted it. Then we have RFC 9218, which Kazuo and I worked on for extensible prioritization, mainly for HB3, and then we backported it to work over HB2 as well. H1 doesn't really have the problem because it's not multi-streaming, so whatever. Then we have quick datagram frames, which we defined in Quickland. They don't have a transport multiplexing identifier, so you're sending messages, but you probably want to send different datagrams for different kinds of information flows within a connection. So in this group, we came up with HB datagrams and the capsule protocol, which is another RFC, and also proxying UDP and HB, all stuff we should be familiar with here, which is great. The first time I wrote this draft, a lot of those things weren't quite RFCs yet, so we're hedging our bets, but now they are, which I think makes this discussion a bit more clear. You could say datagram information flows multiplexing. Like, what would be the use case for that? Mass proxying is one, maybe quick aware proxying negates that a bit, I don't know. Web transport, potentially two, depending on who's using web transport to do what. We're seeing some proposals in the mock working group about not using datagrams and still achieving the kind of low latency video goals that they would like to do without datagrams. So maybe we don't need this thing. I don't know. What I'm trying to figure out is there any interest in this document? It could be done, but should we do it? And if we did, where might we do it? Next slide, please. So yeah, this is the Venn diagram of all of the RFCs that we have and the different working groups that have done them, and things that are HTTP datagrams possibly could have been done in the HTTP working group, but we did them here. There's lots of folks who kind of live in this Venn, but next slide. So just a very quick recap about what this extensible priorities scheme is. It's for signaling between clients and servers, and then there's other thing where you might be a reverse proxy and you want to have an origin or maybe some code within your like maybe CDN world that can also influence the prioritization. So it's a kind of two-way thing, but it's all in the RFC, but we have two signals effectively. Urgency, which is between 0 and 7. It's kind of like buckets of weight or whatever. And this incremental thing, which talks about how the responses in HTTP can be processed. But really it's about, is he streaming the important bytes of content that you care about? How might they be used? Which influences, maybe you want to send all of the one thing in one go and then move on to the next. Or maybe it's useful to have bits of things coming kind of as closely in parallel as possible, because you can render them something like a progressive JPEG or something like that. So in addition to the signals, we give some scheduling guidance. It's not mandatory, but effectively it's there so we can articulate broadly like expectations. So if you're going to use the signaling scheme, it's useful to know how the other end might operate on that, but we can't mandate things because scheduling and resource usage is always within the control of the other side that is sending and scheduling data. So next slide, very quickly. If you follow that guidance, you might end up with this kind of thing. I don't have the time to go into it, unfortunately. Next slide. But when you come to datagrams, you've got these multiplex flows using quarter stream IDs. There's just all one big bucket. So how do you schedule that? Maybe FIFO. Sticking stuff is a bit basic. It could work, but maybe it wouldn't. Next slide. So then you combine that with streams and you've got this one bucket of one thing and these multiple weights of other stuff. It's kind of a mess. Next slide. Then you stick capsules in, and capsules are going to be sent on streams, and maybe they're the same stream, and that they're kind of the hook for the stream and the datagram, and maybe some things are more important than others. Next slide. Oh, that shouldn't be in there. Next slide. So there's this thing, and it adds a thing for datagram urgency that basically accommodate datagrams within like a compatibility mode that would just fit within the extensible priority scheme and its extension mechanisms. And it's all to do with how you might share the bandwidth between datagrams and streams. Next slide. Yeah, there we go. Look, magic. Next slide. Is it a problem? I don't know. Like in the web transport world, in W3C, there's like these big long threads of issues. They just go. Like, wow. maybe we can, maybe we don't. Please let's figure this out and just resolve it because it's been dragging on way too long. Next slide. Yep, and we add another one to our Venn diagram, the W3C at the bottom. They need to care too. Next slide. Yeah, so what do? Everyone's pointing at each other. Can we just put this to bed, please?
All right, if you're gonna hop in the queue, we'd like a thumbs up. This is something we should talk about in Mask. Thumbs down somewhere else, and we'll have further comments on the list or elsewhere.
Thumbs up, but I'll just add when we wrote HTTP datagrams, the prioritization for HTTP, the extensible one, wasn't ready yet. So we decided to punt to not delay. But if it had been there, we probably would have put it in there. So this seems like the right thing to do. Thumbs up.
Thank you.
Inside Mask.
Ben Schwartz, I don't get it. Where's the queue? These are datagrams. There's like there's no streaming here. There's like there should be no buffering here. Like, you know, a datagram comes in, it goes out. There's no, where's the queue?
It would depend on the implementation. You know, if you're doing something like Quick, you probably want to send a flight of packets. Effectively, if that's what you're doing in a proxying model. So you would have maybe a batch of 10 things you send at one time, and you're building up, you know, multiple, say, connect UDP streams that are coming in, and you're trying to dispatch them as quickly as possible. I agree, and they should just be in and out, but you might build up queues. There's no flow control with datagrams, sure. But,
yeah. I don't really understand where the queue is, but if the queue is on the sender side, on the inside, sending from the client to the proxy or from the proxy to the client, then this doesn't seem like the right layer. You want the place where you want these priorities is on the outside of the packet, so you can tell the kernel to schedule the delivery or adjust its buffering in some way. I guess I don't really get the use case. Separate from that, I want to say, in general in Mask, we have an interesting problem with these extended context things, which is we have a way to define these formats, but we don't have any way to explain to the counterparty when they should use it. So I can define a format or a context ID for you to be able to express priorities back to me, but I have no way to tell you whether I actually want you to do that or how often I want you to do that. I think that's a puzzle. Same with sequence numbers, same with all the extensions that we've talked about. I think that's
all right. Before we go too deep into that, this timer, Ben, is your time for the next set of slides if you'd like to do them. So we can talk more about priorities. If you want to take us on a quick tour through your last set of slides, that also works great. Or we can go into recharting. I see slides. Thank you, Lucas.
Okay, well then, to be very brief, I'm also going to be mentioning this at the HTTP working group, but like this is how Mask looks, right? You get a template and then you use extended connect with :protocol. So like, could we just do that for the old HTTP request proxy and TCP proxies? So the TCP proxies are an obvious parallel to UDP, but actually I think there's also a parallel in HTTP request proxies, and I claim that this solves some real problems, because these old-fashioned proxies, they're like completely impossible to virtual host, and also the TCP proxies don't really work well with happy eyeballs. So the specific proposal in the draft has a bunch of intriguing, edgy technical bits, but the bottom line is like, should we do this? Where should we do this? And this is really for the rechartering discussion, so maybe I can just close.
All right, any thumbs up, thumbs downs? Tommy.
Yeah, I find the TCP use case a bit more compelling. And certainly if you're trying to have a new format for the normal HTTP proxying, that should be done in HTTP and not in Mask. I'd want to make sure that if we're doing any of this, we're actually getting enough new functionality. For example, if for TCP we defined the ability to do, star.star to have a TCP listener, like that would be like a compelling new addition that is like fundamentally something you couldn't do today. So yeah, so maybe split the TCP stuff from any other changes and look at having TCP listening.
Thank you. All right. Thank you, Ben. And with that, we'll steal that. All right. Should we get a little wider? There we go. So this is a proposal, and I'm showing it this way instead of a diff view because the diff gets messy when you move things around this much. But the main difference between our current charter and this is this paragraph that I've highlighted partway down. So this is somewhat provocative text in the sense that it pulls in a whole pile of stuff that we had previously said was out of scope. So the intent here is, as we've just been talking about a number of documents, I think we've sorted at least one over to dispatch. We have some DNS conversations of do we want to have that in HTTP or ADD or DNS ops, or continue to talk about that in MASQUE. Whatever we decide there, we will certainly be coordinating with all of the relevant other working groups, and we have some text about that at the bottom of the charter as well, so we can add other groups to that list. And we also had a set of things where it looks like we've got quite a good bit of energy and some really good ideas around what we want to do. So with that, the mic line is open. Let's tear this apart or decide that we love it. Lucas.
Clarifying question, Lucas Party Cloudflare, clarifying question. Could we, what do you mean by core documents here? The stuff we defined only in MASQUE, or the things we depend on from other groups?
Our original three, so HTTP datagrams, connect UDP, connect IP.
Okay, so the priorities example is, it's an extension to a document that was written in HTTP working group, but the extension affects the behavior of the documents we made here. So we're not extending the documents per se, but the behavior. Would that be in scope too, potentially?
David, you want to hop in the queue and say such things?
Sorry, I happen to be next. I think of Lucas's datagram priority as an extension to HTTP datagrams, even if you're right when you get down to the details, they might not necessarily be. So I would phrase this in such a way that it's in scope. This seems a bit, so now to make my personal point, this new paragraph feels a bit too broad to me.
Good. Help narrow.
Yeah, I'm sure our ISG overlords don't want us doing too much stuff, but conceptually, I think it would make more sense for us to focus on extensions to our core documents. Some wording needed here because of previous point. So extensions to connect UDP, to give it more features that we think are useful. Extensions to HTTP datagrams, extensions to connect IP should be in scope. I really like the idea of real-world use cases, except that's kind of ill-defined. So I would like to see that tightened, but I like the concept. Let's not go crazy into hypotheticals. Let's keep it real. And then where I then draw the line at kind of narrowing the scope would be to say that if something applies to HTTP more generically, it shouldn't be in scope here. It should be in scope of HTTP. The remaining thing that's still here is discovery and configuration. I'm not sure that should be in scope, at least because so far all the proposals we've seen in this space are not specific to mask and kind of more general to HTTP and encompassing things like DO or high or all that. So I would perhaps maybe explicitly mark that as out of scope as something that is not tight to our code document. So I would take a chainsaw and probably remove 3/4 of this paragraph.
Beautiful, thank you. So previously we had also discussed splitting discovery and configuration, and one of the reasons I mentioned this as being provocative is we previously had a sentence that said discovery is explicitly out of scope, and this pulls it back in. And one of the questions for our folks who are in the queue now is that something we want, or do we want to keep discovery out of scope? So next up we have Eric.
Can I be heard? Apparently my video failed to start there.
Yes, you can.
Okay, so I'll at least just talk then. So similar to the comments I made in, I don't know, an hour or so ago, and also similar to what Dave was just saying now, I think the big danger here of just being too broad is if we let this working group essentially become the general proxying working group. So I think we really need to make sure that whatever we have written here is focused on only proxying for Connect UDP and Connect IP. If it's related or an extension to those specific topics, I think very broad scope is good. Configuration, discoverability, extensions, all that stuff is good. But I think we really need to focus on proxying UDP or IP. Make sure and possibly explicitly leave out anything that's general to proxying that includes proxying TCP and all that stuff. Anything that's in that area is, this working group is just going to become permanent if we just allow anything that's proxying related.
Beautiful, yeah, thank you. Next up, Tommy.
All right, hello. Yeah, I agree with what I've heard so far. I think the text, maybe rather than saying core documents, should be very specific and talk about enhancements to Connect UDP and Connect IP, or however we want to call them. And be very specific about saying we should be doing work that adds missing functionality that prevents some use cases, or is about improving performance, or text like that. For some of the other things, I don't think this should include authorization. I'm not sure what transparent modification of proxied content means. I'm also I think maybe rather than discovery and configuration, maybe another way to put it would be to talk about coordination between different resources. Like some of what Ben was getting at was, recognizing that, oh, this one server does Connect UDP and Connect IP and Connect. And I think there are functionality use cases that could be related to saying, hey, I want to Connect UDP that has the same local address as my Connect IP, to bundle them together. So maybe talk about more how we are coordinating these different resources. I don't have a specific test for that right now, but that may cover the configuration, but narrowly scope it. And then the last comment, I think it's fine to say that we don't include the TCP stuff and that goes to HTTP. But again, I would bring up like the TCP listening case is interesting, and maybe it's worth bringing up to the HTTP group of like, if someone is going to do TCP listening proxies to mimic the UDP ones, does HTTP want to take that on, or do they want to punt it over to mask, because that's feels more masky than normal proxies.
Thank you, Martin.
Martin Duke. So yeah, I definitely don't want to be the proxy working group. The current consensus, I would say, is that we're also not going to be mask M. And I feel like we are open for any and all extensions to Connect Star is like a mask M charter. Now, I mean, that's not written in stone. We can decide that we want to ask the IETF to become mask M. And if so, great, if there's that much work to do. But maybe we could scope this to actually some actual problems we were trying to solve, like explicitly. And I think this has been a very useful session. We ran a little proxy dispatch, which is fine. And like some things I think have already more or less been booted there. But not today, but like over the next few months, we can figure out like a set of plausible problems that would be put in scope. And if we choose later not to adopt them, it's okay to not deliver all the things that are in the charter. And then we will have a nice stopping point to then reevaluate rechartering, you know, when those like concrete items are done.
Thank you. Yeah, so my follow-up question to that, which I'd written down earlier, was do we actually want to mention explicit documents? And I think mentioning the explicit use cases, we can always swap out documents, may be a nice balance that we want to take.
Yeah, and like and again, I think it's important to say that something can be chartered, we can just not do it for various reasons. That's fine too.
All right, real speedy, Alex.
Alex Shanowski, Google. One of the things which I found really interesting about the discussion today is sort of the overlap between some of the different things that we had. Like, I'm not opposed to service discovery per se, and it's useful in some cases where you wanted to offer, for example, like a DO endpoint on your mask proxy. So I'm particularly interested in figuring out how to put in scope a lot of these like layer breaking things that actually would help us make a high performance useful service. So that is really where I think we should be focusing around those sorts of edges. That way we avoid the like maintenance problem, but we still get like real world use cases.
Got it. Thank you. Martin.
To David's point earlier about the scope of this can be very broadly interpreted. And I think this needs a very specific exclusion clause following all of this, saying that the work will not do generic blah, blah, blah. Because otherwise this is going to, yes, you want to do all these things related to proxying, but you also don't want to go out and define new HTTP authentication mechanisms or all of those sorts of other things. So I'd like to see that worked on.
And David Skenazy very quickly. Yep, agree with folks here. Like maybe not quite as tight as explicitly listing all the extensions that were discussed today as only what we can do, but very tightly like something close to that. So it's not all extensions. One thing that I just thought of that I might want to add, and well, we'll take it to the list, is I've been toying the idea of writing a document that answers the question of what is a mask proxy. Because that comes up a lot of at work where people, I hear someone telling someone else, well, just use mask. And then someone says, well, what does that mean? And we don't have a great answer to that today. I think that goes into like the discussion that we had with Lorenzo earlier of how Connect UDP, Connect IP, how all these pieces fit together. And there might be space for an informational document. And I don't know if that should be done inside this working group, or I can just go dump my thoughts to the ISE. But that's a discussion I'd like to have with the working group if we want to do it here or not. And a recharter is the right time to have that discussion, perhaps on the list.
Sounds good. Thank you. I see Lorenzo cheerfully out of the queue, but at the mic. Let's go fast.
Yeah, I just wanted to say, I think trying to figure out what mask is going to offer. I mean, to me, it's the ability to basically proxy at the fine-grained IP level. Can we basically say that that's the goal, and like all things that everything that is in pursuit of that goal is basically how can a client appear to be at the proxy and still make everything work as if it were, directly connected to the internet. I think that might be a useful thing to put in there to navigate, okay, what is and what isn't in scope.
Yeah, thank you. All right, this is excellent. We have gotten lots of really good input there. We will follow up on the list with some links to very specific proposed text as we go through that. I think we're hearing a good consistency between the last meeting and this meeting in terms of the scope of what people are interested in working on. And also, super importantly, we've got lots of really good energy from folks who actually are providing really awesome input. So thank you all very, very much for that. And with that, that concludes Mask at IETF 115. Thank you all.